We're going to be taking a look at railway-oriented programming today in .NET. And if you come across ROP or railway-oriented programming, maybe even railroad, but I think it's railway most of the time, it's a style of coding that basically there's two parallel tracks. The top track is your general, regular flow, your flow of methods. How is the data flowing through your system? The bottom track is the error track. So if you get kicked off the main track, you'll get kicked onto the error track. So, kind of like diverting railways on a railroad. But they end up both at the same destination, just on different parallel paths. So that is the analogy. And it's kind of an abstract concept, and I haven't seen too many like practical implementations in .NET for railway-oriented programming. So I want to give you one possible implementation, and I'm going to try my best to keep this short. And funny enough, I actually made this video, and it was over an hour and a half long. And then my Rider instance, I restarted it because it came up an error, and I lost all my code. For whatever reason, it didn't save. So we're back doing this again. And so basically, I'm going to write two comments. So we're going to do ROP, railway oriented programming. And so again, there's two parallel tracks, right? So we'll call it normal data flow, and then you have your error flow. I guess we should call it a track to keep the, Thomas the Train theme going here. Normal track, error track, and we have our destination, or, the return, whatever it may be. So if you're used to object-oriented, you're going to be used to, writing code similar to this, and I'll show you. So we'll make this a bool, should print name, something like that. And this is inside my controller, just a heads up, just to make it easy so I don't have to switch files in the video, because this window has to be condensed and I don't want to open up my Explorer and take up my thing. So we're going to put it on the controller, but it doesn't really matter. And if you're used to object-oriented, you might be used to print name as being one method, and then you might, modify. You might use some external state, should print name. If you do print name, you'll use your private methods, print first name, and console.writeLine, my first name, and basically copy and paste that to make it a print last name method here. Print last name, and I'm going to print my last name. And finally, we're going to basically now print, return a string, and we're going to say return full name. And what we're going to do is we're going to have that what should we do here? Print first name. I guess we should say, I'm just going to say, I'll change these to return first name, return last name, and we can still do console, but I'm just going to have it, return Steven. Perfect. Change those to string. Return type to string. Okay. And, again, just showing you the typical object-oriented way of doing this. And now we're going to take first name, string, last name, and then we're going to return that first and last name. Okay, so now we have our three private methods and our main calling method dictated by this state value. So now we can say var first name. What is that? Autocomplete. You see, it's like my data protector thing I have in here. Should return first name. Okay, and let's see if autocomplete does it for me. And let's see if my, what did I call that? Return full name, return full name. And we're going to pass in first name, last name. Perfect. Okay, so, but we only do, we might have else, we don't want to do anything, just return. But obviously you don't need that block. But I'm just showing you the typical object-oriented way where you might have a property on your class, decide what your method should do. So this is not a pure function because this is outside of the scope of this method, and so it's decided by something external in the system. So this is, but typical object oriented, right? If you introduce inheritance into this, it would make it even more object oriented. But this is generally how you would see code is, you call a method, return it. You call a method, return the value, pass the two values into another method, and have that, and do its thing. And these are marked private, and it works. And you could introduce, like, if, let's just say, for example, hypothetically, if this was like, return first name was like calling an external API, right? We injected, HTTP client factory, and we were making an external call. We could wrap, okay, if it should do that, we could wrap, these things in a try catch, and handle the error that way. If any of these error out, we're going to catch that exception, and we're going to throw maybe the exception. We might log the exception. So this is a real typical setup of how you may see code or come across code in an object-oriented world. And railway-oriented programming gets us away from doing this style of coding here. And so I want to show you one of the practical implementations of railway-oriented programming in .NET. So I'm going to just, again, keep it on my controller to keep it simple. But first I want to, let me stop that so it doesn't lag on me. But I want to introduce what's called a propagator block. So I'm going to take some notes here so we can follow along. Propagator block is the interface, and this really dives into the concept of delegates. So delegates in .NET are going to be function pointers, and there's a few, or you might hear them function, basically function signatures. You might hear a couple variations of definition, but what we're going to specifically be looking at are the func and action delegates in .NET. So func accepts an input and returns an input, and action accepts but has no return. And you might come across another one called predicate, which is just a specific type of func that only ever returns a Boolean. And so we're going to be thinking about these two things because what we're going to be working with are going to be transform blocks. And I want to show you what transform blocks are and why they're useful for us. But the first thing that I want to define right out of the gate is going to be a common data object that's going to house these data points here, right? So you can see we have declared local variables, but the hard thing about this is that, this method is tied to this signature or tied to these parameters, right? If we change any of these parameters, we have to change the method signature. If we change, for maybe the type, or if we add one, right? And so these methods are not composable, and you can't bind them together, right? Because they don't have a common return value and parameter. So railway-oriented programming depends on having a object or a class that's going to be used as the data that's going to be sent through the pipeline. So what we're going to be doing is we're going to be defining a class. So we're going to just do it, name. I don't know. We'll just keep it simple. Name data, and let's define our properties again. Ooh, hold on. String first name, and we need a property for last name. And we need a property for, I think I called it full name. So we have the 3 properties here on name data that correspond to all the way up here, these 3 variables that we defined in the scope of this method. So now we've done the first really step. So ROP, we'll call it, ROP steps, right? The steps that get you an implementation of railway-oriented programming. So step 1, define data contract, we'll say. So what that looks like is just make a class, right? Make an object. And so we've done that. So we've defined it as name data. So now we can use name data as our contract for all the blocks that we're going to be using to assemble this pipeline. So that's step 1. Step 2 is going to be, we need to define our method that's going to return us a propagator block. Define method to return propagator block. Let's go ahead and do that. So it's going to be public I propagator block. And you can see that, let's hover over the signature or hover over propagator block and see what the signature looks like. So you can see that the input is going to be, it's a generic interface, so we have to specify the input and outputs. But you can see that it inherits from source block and target block, and that's really going to be the key for how we assemble this pipeline, because we're going to be specifying a source, and then we're going to be linking it to a target or destination. So what we use for the type here for this generic interface is that name data class or object that we made. So once we do that, we have now established, okay, we're going to be sending name data through our pipeline. So we're going to just, create, I don't know, name. We'll create name pipeline. Okay, so now we have our method. So now at some point in time, we're going to need to return a propagator block, but what in the world is that, right? How do we make that? So propagator block is an encapsulation of blocks, and those blocks can be you have transform block like that. You have let me just see if it's not gonna let me. Transform block. You have action block. You have broadcast block, which is a very fascinating one. Broadcast block essentially allows you to spin up multiple threads depending on how many things you have linked to it. So it'll be one new thread per linked block, and it'll run those in parallel. Very, very powerful block. And there's another block, single, man, what is it called? It's like single, oh, here we go. Broadcast block, batch block, buffer block. You may have come across buffer block if you need like a queue, or like a buffer that like a loop can interact with. Write once block. There's a bunch of them. Write once block. You may write once block will receive or can receive multiple sources, but the first one that executes or the first one that completes its task is going to be the one that writes the block. So it's an interesting use case for sure. One of the main uses that I can think of is if you have multiple paths and maybe they have a different implementation of an algorithm, and depending on your data, one algorithm might finish before another. So if you want to execute them in parallel, you can do that with a broadcast block, and then to a transform block, and then to a write once block. It's pretty neat. Blocks are extremely powerful in .NET. They're definitely a what's the phrase, like underutilized piece. They're definitely not talked about a whole lot. So for our case, we're going to be using transform block, and I'll tell you why is because we're going to be making a pipeline, and I always want there to be an input and an output. And a propagator block depends on an input and an output, so the entire encapsulation has to accept something and return something. So we can't end on an action block. And so we're going to be just using transform blocks. Transform block is basically the blocks. It's an implementation of func, right? It's gonna take in a func, and so you can think of a transform block as having the same signature of the delegate func. Action block is basically the same signature as the delegate action, so you can think of it like that. So again, we have to pass in what our inputs and outputs are going to be. We've already defined that to be name data, so we'll do name data, and we're going to call this our first name block. Okay, so first name block defined like that. Let's set that equal to something, and let's let autocomplete do its thing. But I want to see what the actual what is it expecting. So it's expecting a func of name data. Name data is called transform, but then also it has a second parameter called data flow block options, and I'll get to that in a second. So in order to create our anonymous function, let's go ahead and basically capture that data, right? And then do a little arrow, and then we're going to go ahead and specify our parameters here. And autocomplete, I guess, thinks that I want to have max degree parallelism environment at processor count, which is a good thing to set if you're ever working in a parallel. If you're ever working with code that you're going to run in parallel, it's a good idea to have something like this set. So, but we're not going to have that, and I'm going to get to this in a second. But so right now here we have access to data, which data, if we go into that, we'll have what is in that class. So first, full, and last name. What we want to do is, because this is going to be basically, we're making this method here, but in a block. So we want to assign my name to that property on the class. So let's go back up here, and we're going to go ahead and do data.firstName is equal to my first name. And now it's going to complain at us because we're not returning anything. So again, the signature for the output is the same. I want to use the same object. So we're just going to go ahead and return back data because it's the name data. So this is all that block is going to do. I mean, I guess I had this writing to the console. I guess we can do that too. So you can do whatever you want in here. Probably should make this a variable, but it doesn't really matter for right now. So this is all that the block is doing. So we're going to accept an input. We're going to assign that property, and then we're going to return the data again. For the second parameter here, we have a type called execution data flow block options. And I want to bring up one very, very important thing to make sure that you, let's see, actually, data flow block options. Let me look at what are, okay, here we go. Oh, never mind. The other one is the setting I'm thinking of is on a different part of the pipeline. But we can go through these. So bounded capacity, cancellation token, ensure order, max degree parallelism, max messages per task. A lot of these have to do with executing things in parallel, and that's really the power of these pipelines, is that it enables you to run complex pipelines in parallel kind of out of the box. So bounded capacity, how many can this handle? How many messages can this handle? Max degree parallelism, how many, if we have a 4-core processor, we're going to be able to do 4 degrees of parallelism. Ensure ordered, it's not really important for us. I guess I do want to create a cancellation token. So let's go ahead and actually make a new cancellation token source at the top here. I have a video going in depth about cancellation tokens if you want to know more about those, but they're essentially, if you boil them down, they're literally just like flags in .NET that .NET has decided is going to be the thing that allows you to stop like awaitable code. So we're going to pass in my cancellation token, cts.token. Perfect. And I guess for like example's sake, I guess we'll just specify a cancel after. We'll just, okay, we'll cancel it after 1 minute just for the sake of the example. All right, so we've created our first name block, and I'm actually going to just copy and paste this because last name block is basically the same thing, except now instead of assigning first name, we're going to assign last name. All right, so again, probably should make these a variable, but it doesn't matter. So same exact thing, same input, output, assignment, and return the data. Now I'm actually going to, I guess, copy this again, because what do we call this method here? Return, we called it full name. Okay, so we will say, we'll call this full name block. Again, same input and output of name data. And we're going to now make the full name, I guess, yeah, we'll make the full name. We'll see if autocomplete helps me out. Probably not. Yeah, perfect. Okay, so now that's, we're going to get the full name, and I guess we can just do that in the console too. Okay, so now we have these three blocks that, again, kind of directly relate to like the object-oriented, style methods that we had just made. So we have first name block, last name block, and full name block. So we've defined our blocks, so this is good. So now what we need to do is essentially encapsulate these. And so we need to now create a pipeline. And so what you have to decide is, okay, which block is going to be the start of your pipeline? Which block is going to receive that initial input? And for us, we've defined them already in that order, but we're going to start with our first name block. So if you go into your first name block object, you're going to see, well, autocomplete basically spoils the code here, but you're going to see a list of things here, and the important one that we're going to focus on now is link to. So link to, basically, you can think of like if you ever have worked with functional style programming in terms of bind, or just the general idea of composing methods, or I guess you could think about it in terms of C# with link, or in terms of like method chaining. There's a number of different ways to look at it like this, but link to is similar to that. So link to, if we hover over this, links the iSource block to the specified iTarget block. So autocomplete got it a little bit wrong. We want to link to the next block, which is last name block. So once we've created this link, we are then going to want to specify these link options. And if I can highlight one thing in the video, it's very important that you set this propagate completion to true, assuming you want successes and faults propagated throughout your pipeline. So when you ultimately await the receiving of messages through your pipeline, right, when you push and then you receive, if one of those blocks or tasks fault, right, if a task faults, you want to basically say, okay, notify the rest of the blocks that an earlier step has faulted, and then just propagate that fault throughout the whole thing. So this is how you can think about it in terms of we're building the railroad, because I need to now create my next block, so last name block, and autocomplete got it for us. So we're going to link that to the last and final block, which is our full name block. And so if first name block fails, it's going to propagate the fault all the way up to full name block. So it's going to still reach the destination. However, the code inside the block is not going to execute. It's just going to propagate the fault through. But if it succeeds, it's also going to propagate the completion. So it'll move on to the next block. That code's going to execute, and so on and so forth. So now you can see how we're creating two parallel paths, right? We're creating the railroad. We have our railroad for success, and we have our railway for success and railway for faults. And I'm going to show you more in depth how this works. But the next thing you have to do, so once you've defined your links, it's still, complaining about us, saying, hey, we're missing a return statement. We still need to get that propagator block. And how we do this is going to be, we want to return And what you're going to want to do is you're going to want to go type data flow block. And if we hover over data flow block, we can see that it's in the same namespace as iPropagator block. But if we do data flow block dot, the first one right there is one we want. We want encapsulate. It says encapsulates a target and source into a single propagator, and that's exactly what we have here. So now we want to encapsulate it. So it's going to make us basically define the link again, but only the first and the last chain in the link. So in this case, it's going to be, we want to encapsulate first name block to full name block. But again, we've defined the links. So between this is going to be our last name block. The encapsulation is, we're returning all of this, right? We're returning the entire chain. So if we had, I don't know, 100 links, this encapsulation would return all that. So very, very powerful. I don't know if there's any more we can add in here. Can we add a token? No, I don't think so. Okay. So this satisfies our return. So now we've encapsulated our links. We've made sure propagate completion is set to true. We've defined our 3 transform blocks, and we've defined a cancellation token for fun. So now we have this method that we can call. So we create name pipeline. So now we move on to step 3, and that step 3 is going to be, I guess we're not, I guess we're actually implement method to execute pipeline. So now we've, create our method to build the pipeline. So now we need a method to actually, perform the pushing and pulling through the pipeline. So I am going to make this, I guess, return name data, this method. And yeah, let's call it, I guess, get name data. Sure, that's what autocomplete gives for me. So again, just a regular method. But the first thing I want to do is I want to say, var name pipeline is equal to create name pipeline. Okay, so if we hover over this, you can see that it's an iPropagator block of name data, input name data, and it's going to return name data. It's exactly what we want. So I guess for the sake of the example, let's go ahead and just, we know that we're probably going to need a empty instantiated object for name data. So we'll just go ahead and define that above. So now that we've created our pipeline, we have to actually use it. So let's go ahead and see what we get out of the box with with these propagator blocks. So you can see we get some kind of strange looking code here. We get some similar things linked to. We get this complete, which is odd. We get fault, which we were kind of talking about. We it looks like we get receive, offer, release. We get some weird stuff. Definitely is a bit odd coming from more traditional object-oriented programming. But what we can think about is a pipeline. We need to push data and we need to pull data through. So if we think about this, we'll just say, for the sake of our example, we're only going to send a single element through our pipeline, which obviously pipeline's probably a bit overkill if you just have a single thing. Maybe not. It might just be how you want to go about doing it. But for this example, we just have a single element. We just want to push name data through and get name data back with populated data. So what we want to do is we want to basically use the asynchronous. So post is the synchronous version where it'll post an item to that target block. But we want to use send async, which is the asynchronous version. And we want to send that name data. We will have to make this an asynchronous method. So let's go and make this async task. And we're going to go ahead and await that. I have a video if you're curious about where we kind of go into async and await, and how async is literally just a flag to the compiler to telling it to look for await. And it's interesting how the compiler treats this in terms of how it breaks up the code, and you can think about it similarly to how the yield statement works and IEnumerables. It's pretty interesting. So, but anyway, back to this. So we've now sent sent our data through the pipeline. But we haven't at this point actually done anything, right? We haven't actually done anything. We basically offered the message, and that's a good way to think about it. Is we haven't done anything. We've offered the message, so we have to now receive it through the pipeline. But the first thing we have to do before that, it's very, very important, is we have to tell the pipeline that it's done, right? We're not sending any more data to the pipeline. So we have to send this flag. We have to call this method for complete. And let's hover over that. So complete is signals to the data flow block that should not accept nor produce any more messages or consume any more postponed messages. So again, the wording is odd. I found the wording to be strange. The descriptions are strange, but you have to complete your pipeline after you've sent your data. So it's just kind of a nuanced thing. Otherwise, you might have your tasks you might end up just stuck on a task that never completes, and you might get stuck in your code here. So I've seen it happen, and it's very confusing. So you want to make sure that you flag your pipeline is complete. So now the next thing you're going to want to say, okay, well, it makes sense then to, we can say, we want to get that data back. So let's see what options we get. So we have a send async. Do we have like a receive async? And you'd be looking through, and we do. We have a receive async. We also have the synchronous version, get somewhere, receive. Receive is the synchronous version, but we want to keep it async, so we want to receive that message. So this, we have to again await this. So this is going to be that name data type, because that's the output of the propagator block. And you may be thinking, okay, this looks pretty good, because we have defined our data, built our pipeline, sent the data through, flagged it as complete. Now we've received it. But the one call out I want to do here is that I want to ask the question of, how do you know when you've received everything from your pipeline? Because the pipeline is you can think about it as just conceptually as one big task. You have to await the pipeline. And the important thing also is that you have to make sure that when all the subtasks have awaited. And that's I think a big gotcha of this pipeline, is that you have to make sure that all the data that's been offered to it has been received. And the way that .NET gives us to do this is that there is an option for, I'll show you here, pipeline. If we scroll down a bit here, there's a method here that it says provides a task that asynchronously monitors the source for available output. So there's a method here that you can put inside of a while statement. So it'll create this loop. All right, so it'll create a loop that basically will continuously loop back in, on the pipeline until it's done, right? Until there's no more output to receive. And this is important, because this will avoid you getting stuck and awaiting a task that's never going to complete. If you don't do this and you have multiple data elements going through your pipeline, but you only receive one, you're going to have a pipeline that has stuff that still needs to be, completed, received, awaited, right? So for our example, we're only sending one data element through, but if we had multiple, this is absolutely essential. And I guess I can do this, I guess I can make multiple, but we'll do that in a second. But so anyway, now you're in a spot where, okay, this is in the scope of a while. So I guess we're just, for the sake of this example, I'm just going to define, well, actually, we can just do it like this, because now we want to just reassign, let's just reassign name data there, and then return name data. Okay. So now I've set this to be the output. Let's hold on. I'm actually going to change that, because I don't like reassigning that. We'll just call this return data. Okay, and then I want return data to be that, and I want to return, I do have to make it new. Let's say new. Okay. All right, so I set return data to be the output of this pipeline. I will get into a second of how you could do this with multiple data elements, but I might leave it as a single just for the sake of length, honestly, in the video, because you can go pretty in depth about this. But you're going to want to make sure that this is a thread safe operation, by the way. Like if you're doing this, if you're doing this in any kind of parallel fashion, you're just going to want to make sure, you can use like a buffer block, you can use a concurrent collection, right? Just make sure that, however you're appending this data, you're going to make sure it's thread safe. So anyway, for our example, this is what we're doing. So you can draw upon this. So now, once we've done that, we're not done yet. We have like one more step. And once we've received everything from the pipeline and we know for a fact that we are done, we have this other thing that we need to do, and it's this completion. We need to await completion of the pipeline, so that way it all can be good. It all can be done. So you can see, let me just make sure that we have not. Okay. Let's make sure that we covered our bases here. There's a lot of things here. Making sure that there's no dispose. Okay, perfect. So this is really the last and final step. Once you've received everything, you need to await completion. And let's hover over completion. It says gets a task that represents the asynchronous operation and completion of the data flow block. That's the last step. So now we can return the data and we've built our pipeline. So this is a practical implementation of Railway-oriented programming in .NET, and I'm going to call this method, and I guess to do this, we'll just make a new endpoint to call this, I suppose. Why not? HTTP get, and we'll say name pipeline. Sure. Public async task action result. Yeah, why not? Var result is equal to, what do we call that? Get name data? Yeah. Okay, await. Oh. Go get name data, and we're going to just wrap that in a 200 for now, I guess. All right, so I'm going to set a breakpoint here. So I think we covered our tracks here. Let's go ahead and debug this and see if we got everything. This is why this video is going to be so long, is because there's just so many different like obscure things to get right. And we did get an error. Looks like, oh, ambiguous for action. Get name data. I'm gonna make these private. All right, I forgot that I'm in a controller. All right, let me stop and rerun this. I forgot I was in a context of a controller, so my Open API spec was going crazy because didn't see that. What do we call it? Name pipeline, I think. Let me just refresh this. Yeah, name pipeline. Okay. All right, so this is, let's go ahead and try this out, execute this, should hit my breakpoint. So now we're inside here. So let's go ahead and step through this, and we're going to go into this create name pipeline method. So we're creating my cancellation token, we're creating the blocks, and we're going to make the link. And I do want to show you what this object looks like, and I don't want my cancellation token to get out of here, by the way. You can see that we have the source, we have the link targets, target, which should have the link target. Yeah, so it's kind of an interesting data structure. You can kind of see, you can kind of go through and see the linked in the, all right, so we have our link target, which is our transform block. So you can see that, but I don't want my cancellation token to expire. So I sent the message through. Now I'm going to like go into my while, and now I'm going to receive that data. And let's go ahead and drill into this, and you can see that first name, last name, full name. So my pipeline has worked, and we're going to go ahead and exit out of that, completion, and we return it. And let's go back here, and here's my data that we got through the pipeline. And so I do want to show you, so that's just a really, simplistic example of how to build pipelines, but they're insanely powerful. You get so much out of the box with these things. But I do want to show you one more thing, because I think it's, well, a few more things, because this is why it's so, this is where really a lot of the power comes into play here. So when I build my links right here, and I specify propagate completion to true, you'll notice that our errors, we're not like, nothing is like explicitly like, it doesn't seem like we get very tight error control, right? Let's go ahead, actually, just for an example, let's make one of these throw an exception. So we're not going to return data. We're just going to throw new exception, broken first name. Okay, let's go ahead and make this throw an exception, and let's just see what it does. Let's see what it looks like. Again, because we have specified that, and let's go ahead and go back to here, and let's execute this. Oh, I have my breakpoint set. Let's go ahead and, okay, perfect. We throw the exception. You can see that here we go. So I get my aggregate exception. One of my errors occurred. But then you can see it almost looks like it's necessary. One of my errors occurred, broken first name. And you can see the error is a little bit kind of cryptic at first. This is because pipelines are, this doesn't get us as tight a control as we might like. Like, you can throw an exception here, and it's going to break the pipeline, right? We're not going to print the rest of anything in the console, right? Because it stopped, right? We know the pipeline is going to be stopped. But let's say we want to expand upon this here. We want to have a little bit tighter control and actually know like when one of our pipeline blocks faults. That way we can basically register a callback to happen and introduce the possibility to add in custom handling of that. So I am going to make a new private method, and we'll just say register error handling callback, because I think that's probably the best description of what this actually is going to be. So let's go ahead and set this method up. So I want to basically, we think about these links, and we're taking the first name, linking it to last name. But I want to introduce a step basically here to say, okay, we can think about this as like linking the completion, but I want to add an explicit link to the error. So say, okay, I want first name, but I want to register a callback to happen upon error in this block. So that way, if this breaks, a callback's going to happen in between here, upon completion before it gets to here. So to do that, I need to basically accept. Not that. I need a data flow block. And we'll call it target and data flow block. Data flow block. Wow, if I could spell. Data flow block source. Okay. And it's going to complain at me because I need to specify it might be, whoa, hold on. What did I do there? Wait, what in the world? Huh. That'd be I data flow block. Okay. We need to use the interface. So I've defined this, or I'm making this method basically with parameters of target and source. And we can make these the interface for I data flow block. And I want to do a couple things. So let's go ahead and start going into that target object. And you can see we get a couple things here. So right out of the gate, we get fault, completion, complete. And the one we want to work with is completion, because that is the gets a task that represents the asynchronous operation and completion of the data flow block. And that's exactly what we want, because we want to know, we want to get access to that task, that completion task, because every one of these blocks has this, right? And that's how it's easy to get stuck in a pipeline if you don't properly signal to your pipeline that we're done and await completion of it, because every block has its own sub like completion task. And that's how it's easy to get hung up, is because this guy right here. So we have on the completion, but what we can do is we can register a callback with .NET's continue with. So we're going to say, okay, for this target, upon completion, we're going to basically continue with, and let's go into the signature continue with, or the, oh, is it not gonna, well, I'm trying to get it to show the little dialog box. I know it accepts an action, but I just wanted to show that. Man. All right, so select target. So you can see that it accepts an action. So that is, we're going to just create that anonymous function here. And we're going to capture that task. And because we now are registering a callback, we can check, hey, did that task, did it fault? And we have access to, okay, did that task fault? So we can put this in an if, okay, if it faulted, let's do something about it. So let's go ahead and just, for the sake of our example, we'll say console write line, target block errored, right? Something like that. So obviously super generic example, but you kind of get the gist. And you can say, else, you should have else if, task is completed successfully, right? Then you can, console target block completed successfully. So obviously you don't need else if, but I just want to show you the other option that you have to work with if you don't want to check if it's faulted or not. So this is kind of a neat way to do it, because it allows you to pass in those blocks, but it allows you to register your callback. You don't have to do it like this. You can do it a number of different ways. But again, because these blocks inherit from this interface, we can do it like this. So now that we can register a callback, let's go ahead and basically call that method, and then we're going to pass in that same chain of blocks like this. So we're just going to sneak this between our existing chain and make sure that our links line up. All right, so now we've registered that callback to happen on the task. Let's go ahead and, I tell you what, let's go ahead and set a breakpoint here, and let's rerun this. Okay. There's a lot of setup to build these, but once you have it built, they're so extensible. Adding functionality, adding as simple as adding a new block and adding it to the pipeline. It's so powerful. And this is really where the power of railway-oriented programming comes in, because it promotes this style of coding that's very functional, but has capabilities that kind of blend in object-oriented into functional, but does it in a way where it handles errors very well. And so I want to execute this again. And you can see that, okay, we're throwing our exception in our first name. Let's go ahead and continue that. And you can see now we go into our method here that we have our callback registered on that task. We can see now is faulted is true. So if we step into here, let's go into my console, and we'll see in a second. There it is, target block errored. And we should see that multiple times. We see that 2 times. Okay. Alrighty. Perfect. And I want to explain the reason we see it multiple times is because, again, we propagate that error through the whole pipeline. So every spot that it fails, right, because the error propagated, here. So if we let's say get rid of this, right, and we'll put it in the last name block. Let's run it again. Let's see how many times. Again, we have 3 blocks in our pipeline. And let's go ahead and see where, I should have changed the broken last name, but let's go ahead and run this again. And you can see that it's now throwing in our last name block. Let's go ahead and resume that. Let's open my console. So now, obviously, okay, let's go ahead and target block complete successfully because that was the first. The first block did complete successfully. The second block is where we throw, and that's where we see this error here. And then, okay, there we go. All right, target block errored. Okay, and I do want to make sure that full name block. Okay, last name. Okay. If you want to, it's a bit confusing. If you want to have the error handling, because you'll be like, okay, wait, I thought we had 3 blocks. Why are we only seeing this, propagate once, right? Because the last chain is the full block. So you would have to create like a final, like ending block if you wanted the final block to utilize this callback, right? Because we're never going to be we never pass in this final block as the target, right? So this is not going to be called for that last step. So again, depending on your use case, but this is just showing you how you can implement ROP in .NET. So very, very neat, but I do want to not throw an exception here. And let's go ahead and run this through. I don't think we have any. Let's take off my breakpoint and let's get a feel for what we're working with in the console here for successes. All right, so let's execute that again. Very fast pipeline, and you can see that target block complete successfully, and with the last and final output. So to make sense of the console output, again, we let's run this again. Just here we go. Okay. Here we go. You can see that you see how they're changing order, which is an interesting thing. So pipelines, you got to make sure that you because it's all awaiting, right? Because the first pipeline, it's just going to console write line first name, last name, and the full name. But then upon completion of the first and second block, then we're going to be doing those callbacks. So again, just a couple things to be mindful of, because you can see that the order is a bit different here. The order is a bit different here. those callbacks it's right. It's not going to be like there might be some variation in timing with that for successes, right? For successes, the chain is not going to change, but these callbacks, right? Your one of your steps in your block might execute before, and there's some things to get around that, but just to be mindful of like what registering a callback might do behind the scenes, just so you're aware. So all that to say is you probably, if you are doing this continue with, you probably will want to be like aggregating this data somewhere and having the final result of this error handling happen at the end of like after this, right? Because if you don't, you might get, be subject to like variations of like, you can see, well, those are the same, but that's a bit different. So again, it might be some variation. You can see that because just the timing of tasks awaiting. So my suggestion would be to aggregate that together and place it after here. But again, there's a lot to play around with pipelines. But again, this is just one like potential way to do ROP, Railway Owner Programming, in .NET with propagator blocks. But again, there's other ways to do it. And I kind of want to experiment with using channels in pipelines because I feel like there's a lot of potential for asynchronous communication with channels in the context of pipelines. And the other thing I like about pipelines too is it makes your code a little bit more like a data structure itself. Meaning you have the links, and you can see, okay, this is my target and this is my source. And obviously you can get super in depth in terms of how you make these. But again, this is I see a lot of reason to. Oh wow, was I down here the whole time? Hopefully not. I see a lot of reason to use pipelines. Railway-oriented programming itself is a fascinating concept. It doesn't pop up a lot, but if you do come across it, I would check it out. I would try, especially if you're working with complex steps of code and logic, might be a viable option. So, thank you all for watching. I'll see you in the next one.